Welcome to lesson 8.3, solving for angles with trigonometric ratios. Last lesson, we learned about solving for sides. Now we can do it with angles. I know I just blew your mind. You didn't think we could use trig to find missing angles. Well, we can. That's pretty cool. So, finding angle measures using trig. Alright? I will tell you this. If you know two side lengths of a right triangle, then you can find any missing angle in that triangle. Alright, but you need to know two side lengths. So if you have a right triangle, such as we have here, and you have two side lengths, you could find any of the missing angles. Alright, and I'm about to show you how. For example, if you want to find the measure of angle C, we want to find this angle measure. What you're going to do is the same thing we did in the last lesson. We're going to label our sides first. Alright? So first, I'm going to label my opposite side. So I go across, and I find out that 6 is my opposite side. Alright? Then I know across from the 90-degree angle is 12. So that must be my hypotenuse. And there's no adjacent. So I have opposite and hypotenuse. What I'm going to do, just like in the last lesson, I'm going to write out so katoa. And I'm going to realize that I have O and H, so I need to use the sine function to find the angle. Alright? And now we do exactly like what we did in the last lesson. Alright? We figure out our trig function, which we just did, which is sine. We put our angle measure in, and guess what? There's no angle measure, so what are we going to put there? That's right, we're going to put an x. And then we're going to set up the ratio of the sides. Alright? So what are my ratios? Well, it's opposite of our hypotenuse, so that is 6 over 12. And so what this says is the sine of x, some unknown angle, gives me a ratio of 6 to 12. Well, this is all you have to do to solve this. The sine of x, I'm just going to rewrite this, equals 6 over 12. And what you're going to do is you're going to use an inverse trig function, alright, on your calculator. And what that means is this. You're going to use this inverse function called sine to the negative 1. You're going to use it on both sides, sine to the negative 1. When you do that, you use this inverse sine function, what happens is that your sines cancel out, so you have x by itself. And then what you do is you take out your calculator, which I have right here, and you're going to do exactly this. You're going to find the inverse sine function, which should be on your calculator. Look for it. It's the sine with the negative 1. See right here? Sine with the negative 1. And you're going to do sine negative 1 and whatever this ratio is. So we have 6 divided by 12. Alright? So I'm just using the inverse trig function now. I press enter, and that gives me the amount of degrees now. So x is equal to 30 degrees. Alright? And that's the calculator did all the hard work for me. So the measure of angle C, 30 degrees. Wow! You might be confused. You say, what is that inverse trig function thing? You know what? Let's do it a few more times. Let's get comfortable with it. So, in this example, we're going to find the measure of angle A, and we're going to round our answer to the nearest hundredth. Before we get started, let's make sure we have all our information. Yes, this is a right triangle, and yes, we have two sides. So we are looking pretty good right now. So, let's get started. We want to find the measure of angle A, which is right here. We're going to label our sides, just like we always do. So let's see, across from it is our opposite. So 6 is our opposite, and opposite the 90 is our hypotenuse. So this is our hypotenuse. So we have O and H. Let's see, so katoa. If we have O and H, which function are we going to use? Why not put sin katoa? So katoa. Bruh. So katoa. So we're going to use the sine function, right? Because that's opposite and hypotenuse. So the trig function we're going to use is sine. Alright? Now we're going to plug in the angle measure, but what's that? We're looking for the angle measure, so that is what x is. Our angle measure is x. So it's the sine of x is equal to our ratio of 6 over 10. Okay? I'm just going to rewrite this now. So the sine of x is equal to 6 over 10. And once again, all I'm going to do is use my inverse trig function, all right, the inverse of sine, to get x by itself. So watch how I do that again. All you do is you take the inverse of both sides, all right, and this inverse function cancels the signs out. And so what I get is x is equal to the sine of -1, 6/10. Alright? Just took the sine, inverse sine on both sides. I take out my trusty calculator. Let's clear this out. And we just put exactly this in. Sine -1, not regular sine. Alright? Don't make that mistake. It is the inverse sine of 6 divided by 10, close parenthesis, and we get 36.869. And since I'm rounding to the nearest hundredth, the answer is going to be 36.87. Remember, the second decimal place is the nearest hundredth. So let's just write that in, 36.87 degrees. And that is how it's done. I know what you're thinking. I still don't get it. Well, maybe you do get it, but let's try one more time. Let's really get this, okay? We're going to find the measure of angle D, and then we're going to round our answer to the nearest hundredth. So once again, angle D is right here. That's what we're looking for. So you know what? I'm just going to put the X there now. We're going to label our sides. Across from D is 7, so that is our opposite side. Across from the 90 is nothing, and so that means this must be our adjacent, so 4 is the adjacent side. Well, if I write out so, not sin, so katoa, and I know I have opposite and adjacent, all I'm going to do is find out which function I'm going to use, and opposite and adjacent is my tan function. So, let's set it all one up. I'm going to say that the tan of x, because I don't know what x is equal to opposite over adjacent, which is 7/4. Alright? To solve this, what I need to do is take the inverse function to get x by itself. So what I'm going to do is tan of -1 on both sides. And that cancels my tans out. Yup! Remember, inverses cancel each other out. That's great. So now I got x by itself. I'm just going to rewrite this as x equals tan of -1, 7/4. Alright? Now we just go to our trusty calculator and we go clear this out and we go to the inverse tan, see, with the -1 of 7 divided by, where's the 7? Where are you, Mr. 7? 7 divided by 4. Close the parenthesis and we get 60.25. I'm rounding to the nearest hundredth, so that's going to be 60.26. I have to round out. 60.26 degrees. And that's my answer. Angle D is 60.26 degrees. Alright? I'm going to show you something kind of cool here, right? If I find out one angle in a what's it called? In a right triangle, this is 90 and this is 60. I could always find out the other angle. The way to do that? Well, if I just took 90 and I subtract 60.26, that can give my other angle. And look, I found all the angles. Anywho, let's go on to some word problems. Don't groan. We're going to do these, and we're going to do them right. Oh, even the computer doesn't want to do them. Let's take a look at this one. Ron and Francine are building a ramp for performing skateboard stunts. Ooh, cool, skateboarding. I'm lame. What am I talking about? And it's shown in this diagram. The ramp is 7 feet long, and it's 3 feet high. Okay, so the ramp is 7 feet long and 3 feet high. What is the measure of the angle x that the ramp makes with the ground? All right, and I guess that's right here, as in the picture. We want to round this to the nearest tenth of a degree. So, as we always do, we're going to start labeling. Okay, so we just go across from the angle we're looking for is 3, so that is opposite. Across from the 90 is 7, so that is our hypotenuse. No adjacent given. Well, we've done this a few times. If we have O and H, that's going to be the sine function. So let's just plug it on in. We're going to use the sine of our missing angle is x is equal to opposite of our hypotenuse, which is 3/7. Let's just rewrite this out. The sine of x is equal to 3/7. Let's use our inverse function, the sine of -1 on both sides. That cancels this sine out. and I get x is equal to sine of -1, 3/7. Time to take out the calc. Where's my calc? Clear that out. So I'm going to do sine with the -1 there of 3 divided by 7, enter, and that is my answer. Now if you look here, it said to the nearest tenth of a degree. So the nearest tenth would be 25.4 because I have to round up 1 decimal place. So x is equal to 25.4 degrees. You know what? It'd be pretty good to write the whole sentence here, right? The ramp makes a 25.4 degree angle with the ground. I'm not going to write it out, but I do expect you to do it. All right, full sentences here. All right, we're going to try another example here. A 20-foot ladder is leaning against the wall. We love ladders in math. And the distance from the base of the ladder to the wall is 15 feet. What is the angle of elevation of the ladder? Well, I'm going to explain what this means, but first let's draw a little something something. We got a wall, right? And we got a ladder leaning against it. All right? This is so bad. I'm the worst artist. The worst. Please forgive me. So if you look here, this is my ladder. It is 20 feet. And it says the distance from the base of the ladder to the wall is 15 feet. Okay. We want to find the angle of elevation of the ladder. And the angle of elevation just is this angle. It's with the base of the triangle going up. I want to see what this angle is, the angle that it elevates up at. Okay, so this is our x. Well, let's get started identifying what we know. Opposite the x is nothing. Opposite the 90-degree angle, which is right here with the wall, is 20, so that is our h. And since O is missing and we have h, 15 must be our a. I'm not going to keep writing this out. A and h is a cosine function, so that's the function we need to use. So it's the cosine of x is equal to adjacent over hypotenuse, otherwise known as 15/20. Let's rewrite this out. Cosine x is equal to 15/20. Let's use our inverse function now. To get x by itself, cosine -1 on both sides, cosine -1. Boom, these cancel out, and I could rewrite it as x is equal to cosine of -1, 15/20. Let's put this into our calculator and get some answers, okay? Let's find our answers. So, we're going to do the inverse cosine function, and we'll use 15 divided by 20, close that parenthesis up, and guess what we get? 41.409. Alright, and it doesn't tell us what decimal place it wants it to, so you know what? Let's just round it off to 41. So x equals 41. It should always tell you what decimal place they want it to. Alright, and I guess that's left out here, but it's 41. You got it. Final question. A tree, and I'm going to tell you, we love trees and shadows, so pay attention. We love these in math. If a tree is 28 meters tall, it casts a shadow of 32 meters long. What is the angle of elevation of the sun to the nearest degree? Alright, let me show you how to draw this guy. Alright, let's do a little drawing before we can start this off. We got a tree. That's my tree. Beautiful, right? It casts a shadow that is 32 meters long. So my tree is 28 meters. My shadow is right here. This is 32 meters. All right, the tree casts a shadow. It says, what is the angle of elevation to the sun? Well, if you know, the way a shadow is made is that the sun is overhead and it's shooting its little light rays down. Okay? And so it says, what is the angle of elevation from the end of the shadow to the sun? So that is this angle right here. That is mex. It's not mex, it's x. Let's label the information we know. All right. So across from the x is 28. So that is our opposite. Okay. Across from the 90 is nothing. So that's our hypotenuse, and that leaves 32 as our adjacent. Once again, I'm not going to write it all out. You should be getting used to this. Opposite and adjacent is the tan function. So let's write that. The tan of x, which is our angle, is equal to opposite. Oh, hey kitty. Sorry about that. Got sidetracked. 28 over 32. We are going to take the inverse function of both sides. Man, kitty is getting talkative. I would show you how I talk to him, but you know what? I'm not going to show you my tricks just yet, but I can if I wanted to. This cancels the tan out. I get x is equal to tan negative 1, 28 over 32. Put that in the calculator, and since it's the nearest degree, we can round that off to the nearest whole number. So x is equal to, let's take this out, tan of negative 1, 28 divided by 32. Close up that parenthesis, and we get 41.18 nearest degree, so it's just 41. Hey, look at that, we got that twice. Boom, biggity, boom. So the angle of elevation, which is always right here between the ground and up, is 41 degrees. And that's how it's done, folks. Go kiss your cat because I think it's hungry. Oh wait, no, that's me. I'm going to go do that.